my name is Bob Gazda, and I'm happy to be here with you today to kick off this panel session on the future of cloud and edge computing. I'm with InterDigital. Edge computing offers new capabilities in terms of localized resources with low latency, high bandwidth, especially when deployed in 5G networks, security, for example, keeping data on premise, and many more. As the edge in 5G is evolving, it's becoming more than just compute, storage, and networking, but also offering specialized services such as GPUs, programmable hardware like FPGAs, and value-added services such as video analytics. The edge can be viewed as an extension of the cloud, or sometimes not. And indeed, the promise of edge is clear. In a recent global survey by Censuswide reported that almost half of the surveyed companies were actively interested in edge. This can also be reflected in the present partnerships between hyperscalers and mobile network operators that are coming out. As the telecom networks continue to transition to cloud native and themselves become systems of compute fabrics, I think it's safe to say the opportunity is clear and growing for operators, device makers, whether traditional handset makers or IoT devices, enterprise and IT cloud providers, to collaborate with each other and bring everything to the next level. So this panel is going to explore the space, specifically talk about the current state and trajectory for edge and the cloud in 5G, then discuss the implications on how these may change or evolve as 5G starts to move to 6G in the future. So I have an excellent panel joining me here today, so I'm really looking forward to the discussion. I'm going to do a short introduction of each of the panelists. Then I would like to ask each of them to do a short introductory statement or presentation. Then we will get into the discussion itself. There is an opportunity for the audience to ask questions, so we very much encourage you to do so. Just take advantage of the Q&A feature in the Zoom platform to do that, and we'll fit your questions into the conversation as best we can. So can you go to the next slide, please? So let's just quickly go through an introduction of each of the panelists, and then I'll get into the introductory statement. So first, there's Benoit Pelletier. Benoit is the director of next generation ecosystems and alliances at VMware. He's also the co-founder of the Open Grid Alliance and the Encore 5G testbed in Canada, as well as co-chairing the Next G Alliance. He serves on the board of 5G Americas and many more. Mark, and I'm not going in the order of the slides there, so I apologize for this, but there's Mark Rudnick. Mark is currently the vice president of technology strategy at Crown Castle, and he's responsible for defining business initiatives, evaluating emerging technologies, and then bringing solutions to market that leverages Crown Castle's tower, fiber, and small cell capabilities. Professor Satya, sorry, Professor Satya, I'm going to skip right to your short name. He's the Carnegie Group University of Computer Science professor at Carnegie Mellon University. Professor Satya is a pioneer in distributed systems, mobile, and pervasive computing. His seminal 2009 paper that made the case for VM-based cloudlets, which are the edge, back in 2009, helped to foster in the current trajectory of edge computing. Sinay Tripathi, he recently joined Google, where he's serving as the head of telco and enterprise edge. Previously, Sinay was the CTO and executive vice president at Mobile Edge X, where he helped to found and launch that company. And then last but not least, there's Vinay Kantekar. Vinay is the CTO of Global Carrier Strategy. He's also an Akamai fellow. So Vinay focuses on Akamai's technology evolution on 5G, IoT strategy, and internet scaling. So I want to thank everybody for joining me. We'll now go through the introductory statements. So I will turn it over to Benoit.
Hey, thanks, Bob. Hello, everyone. So I'm very pleased to be with all of you today and having the chance to share VMware's vision on the distributed edge. So let me start with today's challenges that we're trying to address before talking more about how to address them. So when looking at the prospect of 6G, we quickly landed on two key issues that we must resolve for the current generation. So first and foremost, so these being number one, the internet. The internet is broken. And number two, is 5G too complicated and will 6G deemed as a solution? And to put things into the context, the pandemic has been an important vector of change, a forcing function about the things that are distributed, requiring digital experiences to be rendered on a spatially distributed scale. And preserving the quality of experience is important, and also expediting the need for distributing the edge stitched with multiple clouds stretched across a global scale. So let's move to the next slide, and we'll start with double clicking on the today's internet. So we all know that the data volumes are out of control, and the network has never been as important as it is today. So, but the problem is that today's network is just cannot do the things that we needed to do to unleash tomorrow's most innovative applications. Now, the internet was designed for almost exactly the opposite of what those applications require. Modern application and network services require modern approach to delivering network, compute, and storage resource to meet their needs. An interconnection of peering, which is today relegated to regional data centers and carrier hotels, will need to be everywhere. And today's internet is built from the inside out, with most intelligence delivered from huge centralized data centers. But now, we've got billions of things generating petabytes of data are pulling the internet centers of gravity to the edge. This is why we're saying that the internet is broken. Let's move to the second slide and talking about the current 5G state. So the current 5G deployments, are mainly targeting higher performance bandwidth and network densification with 5G new radios, augmentation of the 5G LTE network. Hence the reason why we don't experience much of a difference, when we are using our 5G phones. But this is reflected in the first three elements of the 5G foundation, represented on the screen as a rough scorecard in order of maturity from the left to the right. Although we've done fairly well with the first three elements, thanks to the great effort by the SP-led 3GPP communities, much remains to be completed. And for some of the broader elements that sit at the cross-section of wireless, networking, and cloud industries. For example, the research community continues to unravel complex challenges, around network programmability and autonomics, which must be addressed before we're able to take a crack at the time-sensitive communications, the most interesting element of the 5G foundation. Let's move to the next slide. So, in response to these problems, is for VMware, the approach is to build the grid. But this is not a simple task, we agree, and it requires a huge collaboration efforts from all key players of the ecosystem. And this is the reason why VMware, is actively contributing to three key strategic initiatives that requires a great collaborative innovation mindset among the industry, the academia, and the governments. If we look starting from the top, we have the Open Grid Alliance that we have co-funded and launched in April this year in partnership with other industry trailblazers to realize this vision. Then you're investing in the Next G research initiative with other high-tech global leaders as part of the RINGS, that's a multi-sector PPP for resilient intelligence Next G system, covered also as part of this symposium. And finally, an important one on the Next G Alliance, launched by ATHIS, where we are defining the 6G vision and national 6G roadmap to advance North American global leadership in 6G. So I'm very pleased. I mean, we are VMware holding many leadership roles, in the steering group, as mentioned by Bob, and in the Green G and Societal Economics Needs Working Group. So we're fully dedicated and passionate about those three initiatives, and we're looking forward, in the innovation journey of the distributed edge. Back to you, Bob.
Thank you, Benoit. Mark, I think you're next.
Thank you, Bob, and good afternoon, everyone. Can we move to the next slide, please? As Bob mentioned, part of my responsibilities at Crown Castle are to look at how we leverage Crown's assets to be able to move into new verticals with existing customers or expand our capabilities. And some of the ways that we do that are through our involvement with different industry organizations, such as 5G Americas, the OnGo Alliance, the Small Cell Forum, and Telecom Infrastructure Project. We also have partnerships with different universities, including NYU, UT Austin, and Carnegie Mellon as well. And we look at helping support the advancement of advanced wireless research through our involvement with US Ignite and the platform for advanced wireless research. There's test beds within New York City and Salt Lake, the Research Triangle as well, that are really looking at laying the foundations and having real world test beds. And Satya will get into this a little bit later on how do we advance not only edge computing, but also new wireless waveforms as well. Can you move to the next slide, please? One of the things that we're learning as we move from different generations from 1G to 5G and then eventually to 6G, it's very difficult for the standards to be able to keep up with the consumption from the consumers. So we're seeing things like a 238% increase in data traffic over the past 2 years. So if we move from 4G to 5G within the same frequency bands, we're seeing incremental changes within the amount of capacity that are available. So as we move into the 6G world, and we've talked about terahertz bandwidth being available, the consumers and industries will certainly be able to take advantage of these higher frequency bands, the more bandwidth that's available, and lower latency communications that should be realized as we move from 5G to 6G technologies. If we can move to the next slide, please. One of the things that we see as we're looking at next generations and 5G is taking advantage of this is the number of the connected devices continues to increase, and that will only accelerate as we move forward. If I look at my own household, we have over 40 devices connected into my Wi-Fi network, and I scratch my head and say, how did that happen? Well, I've got connected devices from my alarm system, my Sonos, the TV set, and that list keeps on growing, smart light bulbs, etc. That enables me to be able to intelligently control the energy utilization within my house. And so if it's just my own personal use as 40, 50 devices, think of that exponentially growing as we move into smart factories, etc. If we can go to the next slide, please. One of the things that's critically important, and we heard through this from some of the previous sessions yesterday and this morning as well, is the interconnectivity. And that interconnectivity will be through the dense fiber backbones. I've had an illustrated example here for Los Angeles. And also we'll see wireless connections as well, being able to provide that backhaul, especially as we move into the higher frequency bands. And then on to the last slide, please. And one of the keys that we're looking at as we move into the next generation is the distributed of the edge intelligence. So that's from a major data center to locations either within venues or at the base of cell towers, manufacturing facilities, etc. And being able to shift and move those workloads where they're most optimally served will be critical as we move from the 5th generation of technologies to the 6th generation. And I think we'll get into further conversations as the panel goes along about the distributed intelligence of the network. And to be able to have that interconnectivity via fiber and compute resources will really be able to accelerate the number of different use cases we see in the 6G world. And I'll segue over to Satya here. He has a few examples. Thanks, Bob.
Perfect. I think Satya, you're up next. So please advance to Satya slides.
Thank you very much, Bob. Thank you for inviting me. The average end user doesn't really care whether his bits arrive by 4G, 5G, or 6G. What he or she cares about is what can it do for me? And so the question is, where are going to be the killer apps that are going to drive the embracement and adoption of these technologies? Next slide. The answer is obtained by looking at the huge differential in the compute capabilities of wearable devices like Google Glass or Microsoft HoloLens, mobile devices like smartphones, and servers, which sit in a rack somewhere. Over a 25-year period, from 1997 until today, the gap has been huge and continues to grow. So delivering functionality wherever you are, not just connectivity, is a really challenging proposition. Next slide. The solution that we developed again in 1997 was to offload computation from the mobile device to an edge located server. Back in 1997, we didn't have the cloud, so we didn't need to think about the edge either. Fast forward to today, this is what the unique opportunity opened up by 5G and 6G gives you. Next slide. We see killer applications for both 5G and 6G emerging from a trifecta of very challenging properties, applications which are compute intensive, bandwidth hungry, and latency sensitive. And these can happen in both cyber-human and cyber-physical systems. Next slide. So I'm going to tell you about two example classes of applications. One of them is AI in the loop augmented reality. Next slide. Human cognition is amazingly fast. A human is able to tell in 4 milliseconds whether a sound is artificial or made by another human. If you're doing AR, VR, head tracking, motion to photon latency has to be below 16 milliseconds, 1/6. And face recognition, which is a very challenging task, humans are able to do it on the order of 300 milliseconds for familiar faces. So if you're going to try and augment human cognition with AI in real time, you better be able to beat these speeds. It is here that the opportunity of the trifecta that I mentioned comes up. And so the ability to provide angel on the shoulder classes of applications which help users in various forms, in various walks of life, is certainly one class of applications. Next. A second class of applications in the cyber physical systems. Next. If you thought wearable devices had it difficult, flying is even harder on compute. A small drone on the size of a dollar bill, as shown in this picture, can capture data, store data, transmit data. The one thing it cannot do is process the real-time captured video and give any kind of results. And so it is to enable this class of drones, which are very small, lightweight, possibly in teams or swarms, that the opportunity arises. Next. A city like Pittsburgh has over 400 bridges. And that's not the only thing that the city government has to worry about. There are lots of other buildings, other infrastructure in general. The ability to cheaply and efficiently investigate infrastructure, maintain it cheaply, this is the kind of use cases that small, lightweight drones combined with 6G and edge computing can deliver. Next slide. The opportunity is to create seamless, real-time computer vision pipelines from teams of these drones working in tandem with a human-in-the-loop operator who's only fed the highly filtered and downsampled valuable data from the investigations. So I see here many, many exciting opportunities for 6G and edge computing, and we'll look at those with my colleagues in the course of this session. Thank you.
Excellent. Thank you. Thank you very much, Satya. Sine, would you like to go next, please? Sine, you're on mute.
Hey, good morning, everyone, and thank you for joining us today. My name is Sunay Tripathi, and just a little bit of intro and what I'm doing. The edge journey started somewhere about 4 years back when Deutsche Telekom was trying to figure out what else can 5G do. And some of their thinking was based on 5G as a new architecture. It's a major shift, given the latencies, lower latencies, and higher throughput. Trying to get all the traffic to the core and to the cloud is not going to be easy, right? The investment necessary to uplift all that processing to a cloud will require an investment in backhaul networks that just is not feasible, right? So if you go and look at the use cases Satya presented, and some of the things that Mark was talking about, what ends up being that getting all that traffic to centralized data center typically would need a lot fatter pipes and higher latencies, right? So the goal was, the way Edge was structured was hey, and this is a goal that was given in 2019, 2020 timeframe, that how do we get compute processing closer to users, primarily to enable new experiences, right? And the key purpose was that how can you offload some of these devices to the edge and to the nearby compute, do that seamlessly without people realizing it, take mobility into account, because a lot of these devices tend to be on not static, right? Smartphone, for instance, we don't stay in one place. We go from home to office to other places to venues, and somehow you need to recognize that and offload that and be able to do that, right? Then also the other place was swarm intelligence, right? I mean, how do you deal with things where you have a hyperlocal set of connected devices, be it unmanned cars, drones, where they have to collectively do something, right? And you can go and approach that on a peer-to-peer manner, but oftentimes it's a lot easier to deal with a star pattern where there's a single brain driving a bunch of these things, except that the brain cannot be too far away from these devices, right? So those are the the driving factor that Edge started out, and these are some of the things that we were enabling at Mobile Edge X to help the telcos out. We did experiments with traffic pedestrian safety, where a car driving through the city, and also a pedestrian who is 5G and edge enabled, the system will recognize that the car might on the turn has a blind spot and should warn the pedestrian and the car both, basically, right? Now those were interesting experiments, except that maybe the driver is also distracted, right? So the part that we started thinking about is that at what point can you go down to the part where the car should brake automatically, right? And that's where the concept of smart cities and smart campuses started coming together, right? Fast forward a little bit, a lot of talk. We also realized that this requires a lot of investment, basically, right? Edge has to be ubiquitous. It has to be, it requires a lot of architectural changes and so on and so forth, right? My current job, where I head the Edge at Telecom Edge at Google, started about a few months back, basically, right? And primarily because Google is very serious about Edge and Telecom Edge, and Google start realizing that this is where the future lies, basically, and we need to go and address that, right? Because people need that, and this really solves a lot of problem for people, right? So it also kind of serves well because what ends up being is Google is fairly distributed data centers anyway, right? So I think we are starting to look at edge in a new light here, and we are starting to see things around, well, the vision is great. We know we're going to get there. We need to get there, right? And we probably have 10, 12 years to get there as these applications and these devices come through. How do we get to that, basically, right? How do we bootstrap ourselves? What makes sense today and what makes sense tomorrow, right? So in that light, kind of, we need to start with modernizing some of the telecom infrastructure itself, right? Because if we are going to put these edge and connected things, connected infrastructure in the telecom networks, and devices need to discover that kind of, seamlessly. What makes sense is that, that infrastructure be as modern and as agile as, cloud is, or cloud needs to be, basically, right? So that's kind of, the little bit of a journey. And as we go through this panel, we can explore some of more things, because cloud coming into this brings some new technology capability that wasn't there before when they were sitting outside. And then it also gives us a lot more resources to go and address edge. So on that note, let's go to the next panelist.
Hey, excellent. Thank you, Sinay. So Vinay, you are last in the introductions, but certainly not least. So looking forward to hear you.
Don't worry about it. So hello, everybody. My name is Vinay Kanitkar. I'm at Akamai Technologies, and I'm never sure how many people have heard of Akamai or know about Akamai. We're one of those invisible companies as far as most people are concerned. But to talk a little bit about Akamai, so we're primarily known as a content delivery network. So a lot of the big companies around the world, content providers, banks, retailers, whatnot, use our infrastructure to deliver a lot of their content to their customers. And the primary philosophy for Akamai has always been to bring our infrastructure as close to end users as possible. So it's how we started. So, I started at Akamai in 1999 when it was a tiny little startup. And so right from, day one, our goal was that we bring our infrastructure, and therefore the compute and the storage and the caching or application processing capabilities that go with it, as close to the users as possible. So it's something we've pursued, for our entire sort of lifespan so far. And so we have about 400,000 machines, and we've cycled through many more machines as we replace old machines with new ones. But we have 400,000 machines across the world today in about 4,200 locations, and deployed within about 1,300 networks. So that's really something that we feel very strongly about. And for the most part, because we were putting servers right outside the access networks, we saw ourselves as what was possible from an edge perspective as far as the internet was concerned, right? We are an internet company. Right from the start, our customers look at the internet as their primary mechanism, more and more, in fact. And and this usual example that back in the day when we first started, the internet was small images on web pages, right? Static web pages. And when it worked, when you clicked on a stream and it didn't work, you just took it as this is the internet, right? You didn't complain about that very much. The expectations of the internet, the internet's gotten better, but the expectations of the internet have risen even further than that. So when the stream doesn't work, you are on Twitter complaining about it. You're calling out to your service provider or the OTT provider for to figure out why it's not working. And those expectations have basically meant that we have to constantly look at what we are doing to see whether we are able to stay ahead of what people will ask next. And so when we started looking at mobile about 10-ish years ago, that's really how we approached it. How can we go beyond where we are today at the edge of the access networks into the networks themselves? So it was a bit of a challenge with LTE, as you all probably know, but with 5G and the capabilities that people are opening up for third-party infrastructure, we are looking at more and more how we can go deeper. And we have a few examples where we have done that. We're trying, interesting new things out where we can integrate with the networks and learn what's happening in the network so that it can inform not only the user experience, but also what the content owner tries to accomplish. And really that brings me to the key point that in the last 20 years, what we've realized is that every single time applications define what edge they need. And one of my favorite examples is a self-driving car. If you think of a self-driving car, I don't think we will ever reach a stage where a self-driving car will offload the compute to determine whether it should press the brake or not. All of those sensors, all of that compute is going to go with the car because that's a crucial capability. It has to be that's the edge as far as that computation goes. But there are many other applications where you're essentially looking at a hierarchy of edges, all the way from whatever the device is to the cloud, where different applications will create their edge based on the performance they need, the compute they need, and how much it costs, how much, in what time frames they can make it elastic or not. What are the data locality or privacy regulations or requirements that they're trying to match? How does their power get created? Even from a sustainability perspective, we see customers who only want to use locations we have that have renewable power. So there's so many considerations that go into what people want for their applications that I think for sure we're going to see us deploy more and more, into networks, even a federating across networks, as some people have, sort of prophesied, but also looking at sort of creating edges dynamically, even scaling them, relocating them based on what that use case is at the moment and what it's trying to do. So that's really what, where we are looking at today from a technology perspective, and I think we're going to learn a lot about that in this panel today. So Bob, I'll hand it back to you.
Excellent. Thank you very much. So now we'll get into the open discussion. Okay, I think we just heard a lot of interesting things there from our panelists. Benoit was talking about the internet being broken, and if I maybe summarize it, a bit centralized, and 5G being too complex to kind of work with. Mark, you mentioned distributed intelligence, right? Intelligence distributing around between venues and enterprises and networks. I don't know if I had the dates right, but Sine, I think you mentioned what will things be like in 10 years, which is 6G. So that sounds quite good. And then Vinay, right? Distributed edge that dynamically forms, right? And federated across networks and things like this. These sound like interesting topics. So what I'd like to do for organizing the discussion here is that, the premise of the panel here is to talk about where we are today, or where the trajectory of edge and cloud is today for 5G, and then see where that goes in the future. So, and I know we talked about that in what everybody was just saying. So maybe let's just touch on that from a real high level. Then we'll drill a little bit more in terms of technology and commercialization and things like this. So I'll just pose this very broad question, right? How could we classify the state of where we are today, right? How far we are as 5G is rolling out, and 5G itself is at its very early stages, right? So there's plenty of 5G evolution that's going to take place. So where are we going to go as 5G evolves? And then what do we expect to come next, and what's going to drive? Maybe it would say, like, what's really driving what that evolution would be. So who would like to go first? Satya.
So I would characterize the state of where we are as people are deploying the infrastructure. But as I mentioned in my introductory remarks, people don't care about the infrastructure. People care about the new capabilities they enable. And so what I see is a chicken or egg problem, that the implementers of novel, high-value applications are holding back because they're not sure how real this 5G is. And conversely, the people who are investing in the rollout of these networks keep looking around and asking, who is really asking for this? And so breaking this logjam is, I think, the single most important thing that the industry could do to help itself.
Okay, go ahead, Mark.
Yeah, a couple of comments, and I agree with what Satya's saying. So as we talk about where we are in the state of the rollout of 5G, so most 5G networks today, especially the commercial networks, are still tied into a 4G core. So we haven't really moved into that true 5G infrastructure with low latency capabilities at this stage. And we've heard in some of the previous sessions as well about the tie-up between the wireless carriers and hyperscale players. And they're talking about rolling out on the order of 10 or 20 or 50 different combined locations. As we move into this more ubiquitous compute fabric, that's going to increase by 10-fold or 100-fold. So as Satya laid out, we're in the very early stages. We have to have that infrastructure in place for people to take advantage of it. You know, what is driving this? Vinay touched on this earlier. Think about CDNs and how that improves the user experience for streaming services. That will be the same type of an application that we look at as we move into 6G networks. It will be about the end user experience, or the end enterprise experience, and factory experience. Those use cases will really drive the need for this ubiquitous compute layer.
Yeah. No, I agree. And I think that one thing, you know, and I mentioned that in my intro, I think I validated the two problems, the need to address, you know, the complexity of 5G. And I think also to what Satya was saying about, you know, maybe the end user don't care, but the technologists and service provider do care, because we need to deliver that experience. And the second one was, I think, the provocative statement about the internet is broken. So I think that on the complexity side, you know, it's good to see that we're learning from the 5G journey. And this is something, to me, is important, because we're focusing on two important aspects. So the first one, if we want to have the proper evolution because of the current state and where we want to go, we need to monitor and assess the evolution of the key change vectors, you know, not only related to the technology evolutions, like the spectrum, the radio, the compute, web, data, material, even the energy efficiency, we're talking about sustainability, but all of this in an holistic approach, because I think that we need to look at the societal evolution, you know, and how this is evolving, and then take a conscious decision to build, you know, from ground up, you know, with the green G as an example, awareness. Mm-hmm. And that's going to be important, because we cannot just continue. You've got, you know, Ireland, and it's going to get maybe 75% of their electricity power just for serving, you know, the cloud. So the second one is the early awareness and focus to address the operational challenges associated to the deployment of the next G solution. And I think that AI machine learning will play an important role. I think we all agree. To reduce such complexity of those 6G technology and accelerate the deployment and adoption. Because, you know, until we get there, you know what happened in 5G, we were, like you were saying, we are still waiting some time to say what's the killer apps. With respect to the internet evolution, the thing that what we're proposing is basically is to reimagine the edge. So our vision, it's aligned also what you were saying, Vinay, it's the internet of the future is that a globally distributed grid, you know, which creates together a fabric of heterogeneous compute, data, and intelligence to enable what we call context-aware, immersive, and even distributed modern applications at any time, anywhere, and of course, on demand. And the vision for the grid, you know, is driven by applications that require fungible resources to be allocated at the right place and at the right time, because especially with mobility, if you want to have an experience, you need to be closer, because now 5G is enabling, the ultra low latency, but we need to be able to deliver the power of what we want to implement as the new next gen. And the fundamental of the grid is really about the virtual data center. We're saying it's important to deliver logical pools, the adaptive compute securely and timely. We need to make sure that this is addressed while spanning, in multiple geographies. And finally, I think that the autonomic control accelerate the automation, effectively turning the grid into a self-organized and self-optimized construct, and going about the complexity of the operational mode. And I think that's going to be important. Similarly to the power grid, you've got producer and consumers that they now need both, or utilize capacity of the resource, but they also extend the grid by adding new or ending back, spare capacities. So these three advances facilitate, what we call, hyper-composed application. So that's what it is. It means dynamically composed application with the right type of resources, the right amount, at the right place, and at the right time. So with intelligent, optimization across all 4 dimensions at all times. And I think this is what we need to make sure, and make sure that we are ready to address those challenges.
Right. I think we need to be, from a technology perspective, ready to address those challenges. I mean, some of it will just be driven by the economics of it, like Satya was saying. A lot of infrastructure investment waits for the sort of tenant revenue generators, and vice versa. But there are some people who can afford to invest ahead of the need, and I think we're starting to see that. But yeah, we will build we can build the technology and be ready for that.
Let me add to what Vinay just said. Some people are willing to invest and have the ability to invest. Yes, I work for one of those companies.
I was thinking of you, in fact.
But I think for the panelists, we should for the audience, do a couple of things. One thing that is very obvious is that even at the scale Google operates, the amount of investment necessary, we can't just make that happen, basically, right? So it has to be measured. So getting into a little bit more short-term view, because I think we covered the longer-term view quite well, and what we are doing right now, and also picking up one of the questions that popped up there. It's an anonymous attendee's question saying that Satya presented some killer apps. What do other panelists agree and or have others? And what are the game-changing use cases for the future cloud and edge? That is a question that was asked by an anonymous user. And I think we all kind of agree on some of the use cases Satya presented, right? That they are, that's kind of, where we are gonna go. I don't know who will make those apps. Some of them already exist, guys, right? I mean, if you see some of these demos, they are mind-boggling, right? The only reason they haven't become very prevalent is because they need the scale of infrastructure to reach the masses, right? A global mass. Otherwise, they don't quite work, right? And that's why you see a lot of my fellow panelists are kind of focusing a little bit on infrastructure and distribution and dynamism of creating the edge and so on and so forth, right? But what I'm trying to figure out in this journey is, and I'm more of a doer, basically. My role is generally a doer. So the goal is that, okay, is someone willing to invest, say, I don't know, a couple of $100 billion to get this seeded out, right? Without a clear use case. That doesn't quite happen, basically, right? So what we're trying to do is that if you look at Google, for instance, we have already pretty distributed. We have properties all over the place. Google Cloud is fairly distributed to begin with. And then on top of that, we have kind of, different kind of infrastructure, right? There's, gaming infrastructure out there. There's obviously CDN infrastructure out there and whatever, right? So one of the things that you start looking at is that, okay, our operating costs for managing these different infrastructure itself is fairly high. But edge will need a lot of orchestration capability and automation capability anyway. So can we go and address what we need to do today anyway with a mind on, hey, edge will need those capabilities too, right? And that's how you pay for some of these orchestration capability, because your need is today, right? Then second part, we start looking at it, why the 5G requires, keep in mind, 5G itself is pretty distributed, right? And telcos today spend a lot of time and effort in trying to figure out where to place the antennas and where to do this and how do you go and do that, right? And interesting thing, coming to Google, I found these interesting things here and there, things that they build around spectrum analysis and kind of, topology and propagation delay analysis that combines with geodata. I'm like, okay, guys, can we get that? Can I have that, please? Let's go and take that on the edge and take that to the telcos out there to help them actually lower the investment and do 5G better, right? So I'm going to stop there, but I think the theme here is that to enable those killer apps, the killer apps already exist. I think we need to somehow get these apps out to the masses, right? And it won't be we're not going to reach 7 billion or whatever the scale of the planet is right now. But the goal is to go and reach the population densities and start from there, basically, and then somehow pay for that using our current needs anyway. And that seems to be the theme, basically. Bob, back to you.
Okay, so I think a theme we're hearing here is the edge is going to distribute further than it is today, right? I think we can agree to that, right? The edge is, at least the edge in 5G networks is early on. Maybe just as an example, right? AWS is launching their wavelength service with operators through the world. That's generally positioned at central office aggregation sites, kind of what Benoit was mentioning, right? Where it's, those aggregation sites are not highly distributed yet, right? So that's the best you can do. I think we are all agreeing that that's going to distribute further, right, as we go on. Where do you see that changing, right? Do you like in 5G, when do we get further past where we are? I know we're talking about that. There was an audience question about the device, right? We're talking about the edge as infrastructure, but what about the device? So I'll kind of twist that question a little bit. Do we view this as a continuum of compute from devices to these edge nodes to the cloud, and how are those going to change and migrate around each other? And is this a technical problem, or is this like a commercial problem on how these providers interact with each other? I know that's a lot of questions there, and I'll stop.
So, I mean, like I was saying earlier, right? For a self-driving car, its own analytics and deciding whether or not to push the brake, that's a on-device compute. You're not going to offload that. And there'll be many such classes of applications where the device will play a crucial role. But then there'll be many where offloading the compute or offloading the inference engines or the data will make perfect sense, because you have to strike that balance between what is that quality you need, whether in terms of instantaneous response time or whatever, versus how long is the battery going to last, or what is the cost going to be? The cost of expending battery on the mobile device may be much higher than doing it on a FPGA 5 milliseconds away. And so you have to really trade all those off. And that's why we've basically always seen a hierarchy of compute and hierarchy of edges. And I think that's just a given.
Can I add one more thing to Vinay, that what he touched on, and let's just make people understand, right? You will do stuff on device, right? But at the same time, the cost of device matters. Phones are different. iPhones are different because obviously we are used to paying $1,000 for an iPhone. But the cost of device, especially when they go towards, say, a worker safety, towards where they're in public places, I'm talking about cameras and stuff like that. you're doing manufacturing and you're doing a head-mounted display, basically, you have to pay attention to two things: the cost of device, the battery power. You in these enterprise setting, the battery needs to last the whole workday. You're not going to change the device to charge in between, right? And then the third part is the worker has to wear that for the whole day. So if you look at the head-mounted display for some of us who wear glasses, right? Try wearing a head-mounted display for 8 hours. Forget that. Try wearing a head-mounted display for just 15 minutes, right? And what you start seeing is that because the amount of GPU and compute necessary in there, A, you need to be plugged into a wall outlet to keep it charging, and B, it's so heavy and so cumbersome, right? So you need to figure out that offload capability, right? So the devices need to, some really critical stuff will happen on device, but a lot of these non-critical stuff needs to go off the device. I don't know if our other panelists want to add something. Go for it, Satya.
So I want to pick up on what Vinay was mentioning. He mentioned quite correctly that if you have an autonomous vehicle, yes, the obstacle avoidance is clearly onboard functionality. You have a huge advantage in that a vehicle is already carrying passengers compared to the weight of a couple of grown-ups. The weight of a high-end compute, even with the GPU, is pretty modest. But in the questions from the audience is a point that I think is very important, which relates to what Vinay said. The question that is asked is, does the infrastructure have a role to play even in something like autonomous vehicles? And the answer is yes. So let me give you an example. Let's say one of the example use cases for onboard accident avoidance is a child running onto the road to pick up a soccer ball that he or she had kicked. You have a very short amount of time from the moment the child appears or the soccer ball appears to actually stop the car, right? So this is really accident avoidance. However, remember that in the infrastructure, the video cameras could have seen the child dribbling the ball and could have estimated the likelihood of the child running onto the road. So proactively alerting the vehicle, you may need to stop. So my point is, there is a unique opportunity for both intelligent edge devices like vehicles, combining with intelligent infrastructure to produce a whole that is much greater than the sum of parts.
Yeah, I fully agree. I think that it's blurry. I mean, even in the edge, where is the edge? The edge is everywhere. I mean, you couldn't say that it's at the edge near the antenna. It could be your device, could be the edge, and things will do. And I fully agree with you, Vinay and Staya, with respect to, in no way, security will be at risk in offloading those decisions that require, the importance that may have an impact on security. But getting the infrastructure ready to support, and even vehicles will have a capability as the edge to provide, maybe back some resources to get some power, because the reality is that there's some cost. So who should pay for the edge equipment? So the service providers or the one who wants to deploy this kind of service for private 5G or any kind of networks like that needs to take that into consideration. I think that this is going to be important, is the how and what are the elements, including what was said earlier about where do I put, if it's not latency sensitive, where do I put this data, and what about sustainability criteria that needs to be taken aside the typical standard one. I agree with the security and those kind of things are very important.
So we have about a little less than 15 minutes left in our discussion here, okay? So I'd like to touch on two things. Are there any, and the two sides, one is technology and then one is commercialization, okay? So are there any key technologies or advances that are required to create these visions that we're discussing here, or are we good? I mean, are we good technology wise? So what maybe we can just do a round table around everyone, right? What key technology that you think is needed or advancement is needed that's required to create this evolution that we're envisioning?
I can start with that. Couple of technologies that, Bob, we are looking at is, and I've been looking at personally for the last 3-4 years, is if you look at a lot of these applications we've been talking about, they require a lot of compute of different kind, right? Accelerators of different kind, be it FPGA, be it GPUs, be it whatever it is, right? And two things that we are seeing in this and across the discussion, we're dealing with a lot of mobility. We're dealing with people who are not fixed in a place. The users are not fixed in a location, right? They're changing, they're coming and going basically, right? Which means that whatever we need to do, tying a user or application and a use case to the backend infrastructure, we need to really make it very dynamic, right? I mean, you need to be able to switch things around very quickly. I mean, for a lot of people in this audience, I would take you back to, if you remember the movie 2049, the Blade Runner movie, and you see the scene, Ryan Reynolds walking through that bridge and all the displays and all the advertisements interacting with him, right? At the same time, they're interacting with another person and another person and another person. Keep in mind, these people are there for 10 seconds, 5 seconds. You need to recognize who the person is, you need to recognize who the application is or the use case is, and you need to provision the compute and the basically orchestrate it very quickly. I believe that's the number one fundamental problem to solve. We kind of just technology-wise, we're not there yet.
I think to add on top of the comments, Bob, I think we'd all be a little bit depressed if we said we were there. I mean, there's quite a bit of work to do as we move forward. And one of the comments that we've seen is around the orchestration. And so as we onboard new devices and new technologies, there's a lot of discussion generically around AI and ML. Well, we need to be able to provide information into those learning engines to be able to optimally configure, make the networks more energy efficient, develop particular slices for each type of application that we're using. So there's a lot of work to be done. There's been discussions around network slicing for 5G that will advance even further into the network for 6G. And so what is the information we need to be able to get out of the network to be able to optimize all of the different slices to provide the QoS? We talked about different locations and types of edge devices and where that information comes from, be it from a drone, from a street light, from the car, and to be able to collect that data and federate it across different providers. Certainly there's the hyperscaler players, but there are other smaller players that can have edge compute locations too. Business question that you're asking about, Bob, how do we make that happen? So if I'm an application provider and I want to use the hyperscaler cloud for part of my application, and then I have a low latency part of my application that needs to sit with another provider, coordination among those. So there are both technology challenges that we'll need to address, but then also the business challenges as well.
I would say that challenge of federation, you know, of interoperating between systems is both a technical problem of how do you exchange and share resources, discover them, and then it's also a business problem, right? How does that fit into business context and things like this?
I mean, that itself is a challenge because if you look at, given the telecom involvement in this, typically they like to solve all these problems with a committee that sits there and talks for years to create a standard, basically, right? But what we see right now is this is really, really something that you need to solve with open source code, basically, right? And one of the things that at least I've been pushing around is that let's get the basic code out in open source so that people can figure this out. And it needs to be very dynamic, like typical style. You can't make standards right now when you don't even know what you're doing, right? So it really has to be prototype with software, right? And this is kind of where 6G needs to go. 6G needs to go from speeds and feeds to understanding AI and software and dynamism of what we need to do, basically, right?
Please, Satya.
I want to build on what Sunay just said. I vehemently agree with him. You know, there's just no way this standardization approach is going to work. We need to put out the open source, widely embraceable, usable prototypes, get people using. But this leads to, you ask the question, are we missing any key technologies? To me, the biggest gap is democratization of AI technologies. Today, Sunay's colleagues at Google can, you know, write ML code that does amazing computer vision, face recognition, all this stuff, right? But they work for Google. My PhD students can do it, but they're PhD students. To push this into the real world at scale, we have to reduce the barrier to entry for creating this class of applications. Somehow, somebody who is perhaps, you know, a decent developer should be able to pick up in a reasonable, modest amount of time, enough so that they can create or extend some of these applications. I think that gap between what you need to know and how sophisticated you have to be to create these applications and where we need to be, I see that as the biggest challenge. And I think it's going to have to be a combination of companies, all of you from various companies, and universities like mine that are going to have to do this together, because there's no other way.
I would just I'll throw it out to the panel here. I've heard two things where standards is not the way to go to advanced edge, right? That's what Satya, you were advocating, and Sunay, you were advocating the same, right? Yep. Does anyone disagree with that? Does anybody see that there's a role for standards in the edge space?
Well, there is a role at the end when you want to things standardize, but I agree. What we need to do is put in place what we call, you know, agility and led by the industry. So I think that what we need to do is maybe influence them, but start to do the work. So Staya, you were saying about, you know, how do we get there? So this is the kind of things why, like the grid, we've got three work stream, the think tank. It's going to be important to get together with the industry, with the university also to do this kind of review, making sure that we have plans that drive getting together. Then the second one is on the test bed. You know, it's going to be important to have access, because new technology is difficult to get to the market, because, you know, if everybody waits and everybody is looking at something, we need to jump, we need to get together, you know, mobilize the forces, and then create the right environment and establish, you know, a kind of a way to do everything and use the forces from everyone to build, you know, this kind of new stacks or new disruptive technologies together. So this is why I think part of the grid, the testbed zone is going to be important. And finally, that's going to be also the part of the grid market readiness. How do we get together, identify, you know, the requirements? How can we deploy that globally? And again, it's all about getting together, because otherwise, you know, things will go in a sequential manner. We need to change that. We need to get together and accelerate the innovation.
We are almost at time. So we have about another 2 to 3 minutes here. Okay. So we need to wrap up. Okay. And I would like to just pose this question, and maybe we can view it as something we've not already said, right? If that could be true. Okay. So maybe if we go around, so I'd like to hear from everybody if we could. If there's one wish, right? Just a wish that you could have, like, I wish this would be true today, or I wish this in the future, that's going to accelerate these edge computing initiatives and all the killer apps and all the great, the compute infrastructure and open grid and these things that we want. What would it be? So what would be that one wish? Okay. Mark, we haven't heard from you in a little bit, so I'm going to put you on the spot and then maybe we just go around from from you, if that's okay.
Sure, I'll just do a quick answer. And we talked about collaboration. I think we need to have increased collaboration. We've got, as some of the people have alluded to, different companies working on their own with these edge compute initiatives. Luckily, we have the ability to work with Satya and team that's with the Open Edge Compute that bring people together. But if we can have more open dialogue, also as we look through and deploying the edge compute facilities, being able to have those as open interfaces where multiple companies can participate rather than building the infrastructure on their own, I think that will help us scale abundantly as well.
Okay. Vinay?
You know, I was going to say something else, but I fully agree with Mark that collaboration and having a much sort of broader set of conversations today is that key thing that we should be pushing. I mean, there's a bunch of things around how much we are sort of willing to early adopt, early experiment, and I think that's a secondary factor of that collaboration.
Okay, Satya, how about you?
I would say if there was a wish, it would be a investment fund for startup companies that are willing to take return on the future of 6G and Edge itself as part of the return on investment. And so even if there isn't hockey stick growth, if you're able to seed innovation in this space, viewing that as return. So
Okay.
that I would think would dramatically change the complexion of this area.
All right, Sine and then Benoit. So you.
I agree with what Satya is saying. My view would be that one wish would be the modernization of telecom infrastructure, kind of, to the same place where small startups can actually experiment there. They have the ability to get in their environment, grow as they need instead of buying resources up front. If they can actually go and say, hey, at least in a city or a locality, if they can go and say, I need 5 CPU, 1 GPU for a couple of weeks now and then to do some experiments. And I'll pay small, keep in mind, startups get a lot of funding and they know how to raise money. If they can pay for just getting that experiment done, I think we can bring the ecosystem that has been already successful here.
Hey, Benoit, you're last.
Yeah, so I think we need to stop waiting, stop wishing, and just call to action, get together and do the work. And it's, if you are waiting, for governments or you're waiting for something else, things will not happen. So I think that we have taken the action here. Everybody was like, oh, should we? That's a good idea. It's a need. So Open Grid Alliance was launched for that. We've got NGE, we've got those kind of initiatives. Let's get there. Let's do it. Let's do the work. Let's deliver. And because if you're waiting, we're wasting time, and we cannot do that.
Okay, this was a fantastic discussion. As a moderator, I was a little nervous that I'd be able to fill the hour and a half with discussion, but then here at the end, I think we could talk another hour and a half and still have a fantastic conversation. So I'm kind of a little disappointed that we're up at time here and up at the hour. So I just want to thank everyone. This was really a fantastic discussion. So thank you very much.
Thank you
Thanks,
for your
everyone.
leadership.
Thank you.